Now let's try theorem 5.2. When you have a parallelogram, opposite angles are congruent. And by opposite, they mean like A and C. So we want to prove that angle A is congruent to angle C, and angle B congruent to angle D. See, these are adjacent. They're next to each other. A and D are adjacent. A and B are adjacent because when you go around clockwise, from A we come to B next. Or if we go counterclockwise, from A we come to D. Okay? But A and C are opposite because it's not the next one you come to. So what's opposite to D? Well, this is the next one, so it's adjacent. So this is the opposite. So it's adjacent, opposite, adjacent, opposite. Okay? So we're trying to show opposite angles are congruent. So these are the ones we want to show are congruent. How are we going to do that? Same exact proof we just used. If we draw a diagonal, then just as we saw before, angle 1 is congruent to angle 2 because when you have parallel lines, alternate interior angles are congruent. And 3 and 4 are congruent because when you have parallel lines, alternate interior angles are congruent. So we're going to have okay, so parallelogram ABCD is given. And then, we know from the definition, AB is parallel to DC, AD parallel to BC. If you want to write that down to clarify for you, AB parallel CD, AD parallel BC, definition parallelogram. And then we know that angle 1 congruent to angle 2, as we just talked about, and angle 3 congruent to angle 4. Parallel lines implies alternate interior angles are congruent. Then we know BD is congruent to itself. And that's identity. And then we know triangle ABD is congruent to triangle CDB. Angle side angle theorem. And then we know that angle A is congruent to angle C. By CBCTC as usual. And so that shows that opposite angles are congruent. Because notice that we don't got to prove it over for B and D because it's the same exact thing. If we did our diagonal like this, then we've got this is the same as itself, that's congruent to that, and that is congruent to that, and so it's still angle side angle, and we still show opposite angles are congruent. Okay, so that's theorem 5.2. Third theorem, theorem 5.3, last one in the section. So we want to show that first we'll show AX equals XC. Okay, what we'll do is use ABX and DXC. If we can show triangle ABX is congruent to triangle CDX, then we can use CPCTC to say the parts are congruent. Okay, but how would we show these triangles are congruent? Well, remember, by a theorem we've already had, we know that that is congruent to that. And then, since we have a Z right here, we know that this angle is the same as this one. Okay, it's got to be in the crook of the Z. If we go like that, if I draw it out, this, and that, and then I clarify it, we have A, B, C, D, our parallel lines. And this is our transversal, so you see clearly that goes with that, and you can match it back in. And then, on the other hand, if we look at the same parallel lines, here's AB and here's CD, and we take a different transversal. Instead of this one, we use this one. Then we know this is congruent to this by alternate interior angles. So that is the same as that. And then you can see angle, side, angle, angle, side, angle. A pair of angles, a pair of sides, and a pair of angles, ABX and CDX are congruent. Okay, so we got what we need. So we're going to write that up. Now we've got AB congruent to CD by Theorem 5.1. And then we know, I'll call it 1, 2, 3, 4. Angle 1 congruent to angle 2. Angle 3 congruent to angle 4. Parallel implies alternate interior angles. Congruent. And so then we know the triangles are congruent. So triangle ABX is congruent to triangle CDX. Angle side angle congruence theorem. And then, since the triangles are congruent, we know the parts are congruent. So we know that XC is congruent to AX. Okay, and so this is congruent to this, and therefore BD bisects AC because it cuts it into two congruent segments. So BD bisects AC. Definition, segment bisector. Okay. And then you see by a similar proof, if we showed this triangle congruent to this one, or actually, nope, not by a similar proof, sorry, we can just see that this is congruent to this, by what we've already proven also. So that's the same as that, and that is the same as that, So by CPCTC, dx equals bx, and therefore AC bisects BD. Okay, we could just put that in here as part of this. So XC congruent to AX and dx congruent to bx, and then AC bisects BD, BD bisects AC. Alright, so it just goes together. And we're done. Alright, let's work a few exercises.